Okay, so welcome back to the shed. I keep getting questions about the alternator and charging, and what I want to do today is try and break it down into the components that fell. Now, the key thing is that there's basically two parts to this. One is the mechanical element, okay, which is the drive of the rotor here, okay, and secondly is the electrical side. Now what I'm going to do is I'm going to start off with the mechanical side and the failures which probably most of you know about, and it's really driven by these components here. So basically here is the primary shaft. Now this primary shaft is driven by the primary chain off the crankshaft. The alternator clutch sits on here, okay, and in turn that then drives the rotor. Now these plates are designed to slip. I won't go into detail, but basically it's just to control the inertia on the rotor. To achieve that, it basically uses these components here, which is basically a tension spring, a washer that sits on the primary shaft, a steel washer or thrust washer, and a plain Delrin plastic washer. And that basically pushes against here and allows the drive of this rotor. Now, as has been talked about many times, these plates fell. Okay, now I've basically spent the last year investigating why these plates fell. And to be quite honest, there is no one reason, but I think predominantly it comes down to lubrication. So basically the oil pump, basically, as we can see here, the oil pump here basically drives oil into this shaft here, and then basically it protrudes through this little bush here, okay, into this orifice here. Now what I have discovered, I've gone through my stock, and what I've discovered is this bush actually can come loose. Okay, now when this bush comes loose, it actually protrudes out of here and actually stops the oil flow to these plates. Okay, now I've seen this, I can't say categorically that's a problem, but I've seen it on two bikes. So I believe that's one reason why these plates fell, is because we end up with lack of lubrication, so it's shut off when it touches the shaft here on the rotor. The other reason, I've actually done this and tested it myself, is the time it takes when starting the bike for the secondary drive out to this side of the oil pump here to get oil through the system, because it's low pressure, for it to get through the system, up through the gear and out to this orifice. Now I've timed that now, and that's 3 to 4 seconds from starting the bike. So when the bike's starting up, basically there's no boundary lubrication on these two plates. Okay, so people start the bike, they rev it up, these plates go, they pick up and they start scoring, and then it's just a downward slope. And once he starts scoring, I've actually, funnily enough, rebuilt some of these oil pumps today, and I'll put a photograph up of what I found. These create very fine metallic swarf in the sump that can get through the strainer into the oil pump and basically scores the oil pump. Now what I found on one of these pumps today was actually the primary circuit relief valve was stuck open, and the secondary was actually stuck closed. And when I investigated, it was metallic compounds which I believe are coming from these clutches. All right, so that's where we get to. So that's it. So these score. So these are a good set of plates here, as we can see, and that's what your plates should look like if they're in good condition and are serviceable. The second thing is basically the measurement of this spring. This spring should be 31 millimeters. There is a service tolerance on there, but I would say to you, if it's below 30, then it's not serviceable. So I've actually got a couple here. And the other thing is to make sure that you have both the plastic and the steel washer on the back of the plate here. That's imperative, because actually 1 or 2 millimeters on here really does affect this. So basically the problem we have now is once these plates wear, there are no serviceable items. Now I know some people actually grind these faces here. Well, I can tell you that once this plate gets worn down close to this here, the case hardening is removed, and these plates are then just mild still because they've got a case hardener or carburized process. So they basically get worse and worse. So once you get them ground, they will start picking up and slipping, and actually they're like putty then, they'll wear in no time at all. So basically what I've done is come up with a solution now, and I don't claim to say that that I invented this. This is a common clutch component, and I believe that someone in Japan is doing it. But what I've done is I've made it so it can be fitted by any professional who's got a lathe that can do this. So these two plates get machined. This plate has the friction pad bonded onto it, and there we go. So we're back to square one. Now, one thing is with this, it actually has got another one. It's got an additional 1mm to give you the tension between the two. Now, when I put this under test, the shearing of these OE plates with a 31mm spring is about 3.5 pound-foot. Okay, for this to slip, these two to slip on here. I've tested it, and I've put a weight balance on there to check it out. With these new plates I've created, or this friction pad with this special material here, which is designed to run in oil, we're seeing about 4 foot-pounds. So it's an improvement of about between 12 and 15% on the OE items, which I think is fine. So there we go. So that's basically where we get to. So I just summarise again on the oil. The oil flow here is important out of this orifice here, and make sure this bush here is pushed in and not protruding out up to the end here. It should be set back into this shaft. That's important. Second thing is to make sure your plates are in good condition. I would recommend that actually, if you don't want to upgrade and your bike is used for low miles, keep these plates as they are because it keeps the originality. However, if your bike is ridden on a daily basis, then I would recommend upgrading to this friction pad here because you're just reducing any chance of the issue arising. So that's it. I think I've basically covered off the lubrication, the drive, and the mechanical elements of this alternator. So basically, what I have here is out the Honda service manual, and what I've really done is broken down the components. So what we have here is the rectifier, which is this item here. Now this is off a ProLink, it's not off a Z model, it's off a ProLink, but these connectors here are almost identical, all right? In fact, they are identical. They look different, but they achieve the same process. It's just a more modern design. So basically in the rectifier, you've got two parts to it. One is this here, which is the diodes, which basically convert the alternating current off of the stator here, okay, into direct current. Now this is a point of failure, so I've basically marked up on here the points of failure. So this is a point of failure. Now we're going to go through in the second part of this video and show you how to test these diodes, okay? So that's the first part, is the regulator. The second part are these three coils here. Now that's demonstrated basically by this stator here. So the stator here has 3 windings, which are demonstrated here as I've marked in green, okay? And this coil here, that you can see where my finger is here, I'm just going to bring this up to the camera to make sure you can see it. This coil here represents the stator, okay? Oh, sorry, the rotor. So that's this component here. Now we'll go back and we'll do the measurements at the moment. So what I've tried to do in this is demonstrate from this diagram what components are what. This part here are the brushes that push against the slip ring here, basically to energize the rotor and control the charging circuit. So basically this part of the circuit, so I've covered off one part. This changes the output from the stator into DC current. This part of the componentry circuit here controls the voltage onto the slip rings that controls the amount of current and voltage that is used to charge the battery. Now, I hope that is fairly self-explanatory. I can't really make it any clearer than that. Suffice to say that this is to basically convert the AC to DC to charge the battery, and this controls how much voltage and current is put into the battery out of the stator. So that's it. So this is an energized alternator. In other words, it uses current to energize this. It's not a permanent magnet. Some bikes have permanent magnets. So that's it. So we're going to really go through the points of failure on this in a moment, and I'll show you how to test those. But let me show you on the diagram. So the first one, which I've alluded to here, is the diodes. Okay. The second one is the rotor here. Okay. The third one is the stator. And actually, believe it or not, it can actually be the voltmeter that's at fault. So whilst you're seeing a low voltage reading, it may not actually be the charging circuit that is the issue. It may be the voltmeter. And sometimes this comes down to the earth on the voltmeter that causes the problem. So basically, we're going to come through now and we're going to show you this connector here, which is represented on the circuit diagram here. So that basically plugs into the rectifier, which is under the right-hand cover on the CBX. And it's this red connector that you basically see here, okay, that you would see here, okay. So when we come to testing, we'll go through that. But what I'm going to do is go to a real engine here and show you how to do the testing. So that basically summarised. I'm not going to cover off the change in the bearings because this is all about, is your bike working correctly? Is it charging properly? And so I've done the mechanical elements, so that can be addressed now. And now what we're going to do is come back and test the electrical components. I'll be right back with you in a minute. Okay, so welcome back. So now we're going to start undertaking the testing of the alternator as you would find on the bike. Okay, now this cable here goes around the back of the motor and actually plugs under the right hand side cover into the rectifier here. So to get to this cable, you need to access it on the right hand side of the engine. Okay, and the purposes of this, I'm just going to do it here. Now, let me just reset this as off. Now what I do is I recommend people, when they ask me about doing this, just to buy one of these little voltmeters off of eBay. They're about $10 or £7 or £8 sterling. Now what you need to do to test this is set this round to 200 ohms. Okay, so there's 200 ohms here, and then what we're going to do is we are going to, as I said, we're going to measure these windings here on the diagram, okay, which are obviously under here. Before we start though, we've got to zero out our meter. So you can see there, probably see there, I'm getting 0.3 of an ohm. So that 0.3 of an ohm needs to be subtracted off the final reading to give us our readings. Now what we're going to do is here we've got 3 yellow wires. They don't look yellow, but after 40 years you wouldn't expect them to do so. But they're the 3 wires here. So you've got 2, which these 2 here are actually black and white that control the rotor, and on the other side here you've got the 3 windings that go to the stator. Now what we're going to do is just going to put our meter in here. In fact, I'm probably going to go in the back, it's probably easier. And we can see we've got about 0.8 of an ohm there. Hopefully you can see that, 0.7 of an ohm. So we then need to take the 0.2 off of that, so we're around about 0.5. Now what you need to do is just go across all of these, and you would expect to see about 0.7 across all 3 of those wires, no matter what combination you do, which I am. So that's fine. So I'm happy the stator is here. So if we take the 0.2, we'll just do the baseline again. 0.3, okay. So we're about 0.4, 0.5 an ohm, which is exactly where you would expect these windings on this stator to be. So the next thing we're going to do now is we're going to check the windings across the rotor here. So that's demonstrated by that one there. And to do that, we just put it across the back of the two other connectors, the black and the white. And we can see we're getting 4.6 ohms there, 4.5, which is exactly what I would expect. So when you measure directly across the slip rings of the rotor, then you would expect that to measure about 3.5. There's about 1 ohms lost through this cable and through the brushes into the slip ring. So that's good. Now one thing I would say to you is when you test this, just make sure that you crank the motor over first, because actually when I came to test this, to do this test, I did luckily pre-test it. This is reading about 30 ohms, and basically what's happened is just some oxidization's got between the copper and the brushes. As soon as I turned it around quarter of a turn, it was fine. So now we've tested the stator and the rotor as being fine. Okay. Now one thing that, before we go any further, is to actually just check, okay, that you haven't got any short to earth. So now what we're doing is checking across all of these wires here, and we're going to check it to the earth of the engine to make sure there's no shorts, because that will cause all sorts of issues. It causes the stator to burn out. So we can see we're not getting any reading on here, which is what we expect. If you get any reading, there's possibly a problem. So we can do the same on the rotor as well, and we can see. So we now know that that stator and that rotor is good. So it's a case of checking the windings first, and then checking these windings haven't made contact with the engine anywhere, because they will burn out if that happens. Okay, so that's the stator. We know that's all in good condition. Now what we're going to do now is we're going to check the rectifier. And so what we're doing is, again, checking these diodes here first and foremost. You have to excuse the state of this rectifier. I just pulled it out of my stock. It is a bit dirty, but it's functional. One thing you need to be aware of on here, you've got three wires on this connector here. The red wire goes to the battery, okay, and is permanently connected to the battery. The green wire goes to earth, okay, and the black wire here goes to the ignition. So when you power up your ignition, that basically provides a circuit to the rotor and these two connectors here, and energizes the magnet within the rotor. Now, one thing I would say to you, if ever you're a long way from home and your bike stops charging, your confidence stops charging, disconnect these. Just disconnect them, okay? Turn your headlight and leave it on a parking light and ride home your parking light. If you do that, you're going to get probably 3 to 4 hours of ride time on your bike, okay? I've experienced this firsthand, because I did this on my seat, the carbs on my CB, forgot to plug this connector back in, and I got 3 hours riding time out of it. So that shows that this disconnected, your headlight off, you can get about 3 hours riding time. So anyway, that's another point. But anyway, we're here now to test this rectifier, but I just thought I'd make that note for it's a get you home job. So now what we're going to do is we're going to take our probe. So first and foremost, we're going to put our meter onto this setting here, which is test diodes, which is there, okay? And that's also continuity test. So when you put that on, you hear the buzzer go. So now what we're going to do is we're going to put the black lead into the red wire. And now what we're looking for is a reading of about 360 across these diodes, okay? So we're seeing 366 there. Now sometimes this might be up to 500, but really what you're looking for is consistency across all the 6 diodes, because you can see there's 6 diodes here. So we're getting 360 across all of those diodes that way. Now what we do now is we swap the probes over. So we take the black probe out and we put the red probe back in there. Now what we're looking for is no reading. If we're getting a reading, it means the diodes are broken down. Next step, what we then do is move the red probe to the green wire. So that's the green wire and the red probe, and we go back through again. So you can see now we're getting 366, 366, 369, right? So the final part now is we now take the red probe out, we put the black probe into the green, like so, and we shouldn't expect to see a reading. If we do, we've got diodes that are broken down. So I'm confident now that that rectifier is good. All right. So in summary, what we're looking for is the reading of about 366 across this. Swap the wires over, you expect no reading at all. Move it from the red to the green. Check again, you expect 366. Swap them over, and then you expect no reading again. This is all about checking that the current's flowing in one direction across these 6 diodes, which we've just done. So we're happy they're correct now. Okay, so we're about to close off now of this video. One of the couple of things before I go is, key thing to do is to check these connections here. As you can see, these are pretty corroded in here. They will actually clean up. But if you don't have clean connections in here, or corroded connections, you get resistance between these two connectors. They get hot and these connectors will actually melt. I've seen this on numerous occasions. It's a common problem and affects the charging performance as much as anything else. So just make sure that these are clean. You can actually remove these connectors if you're experienced to clean them up. Last but not least is the alternator brushes. Now you always find that one wears more than the other, purely and simply because the rotor's got a bigger diameter on the outside, so the one on the outside gets more wear. These are available and can be sourced for replace, but I would basically say that's probably the minimum that you would want to really go on that brush on the outside. So that's it really. I hope this video has been useful. I will tack a piece on the end, hopefully, if I can find it, of the checking the voltages of the bike running. This alternator, I should point out before I go, is a European alternator. It's smaller than the US version, but predominantly they are very, very similar in terms of the resistance on here. The resistance on the European one is probably 1 ohm, so this is normally about 4 ohms, whilst the American version is about 3.5 ohms. But sort of half an ohm is absolutely fine. So I hope that's been useful. We'll catch up soon.
So we can see the equilibrium at the moment on idle is 12.4 volts. So the bike actually isn't charging at the moment. RPM is 1000. So what we're going to do now is rev the bike and find out the point where it starts charging the battery beyond 12.7 volts. So I don't know if you can hear this, but we're looking for 12.7 volts. That's 12.8. So that's about 1300 RPM there. And remember, this is the European alternator, it's a lower output. So what I'm going to do is turn the headlights on now at that RPM, see what happens. So voltage drops to 12.4. So now I'm going to bring the revs up until the point they'll actually start charging again. So there we go, we're at 2800 RPM and we're starting to charge now with the headlights on. So I'm going to put the indicators on now, which will load another 4 amps. So that was about 3000 RPM, which is about right. So the full output is about 3000 RPM. So I can turn the headlights off now. And we go straight back into charging with the lights off, which is normal for a European model. Headlights on. So there we go, that's looking positive. That's exactly what I would expect on a European alternator. The output of the alternator is just about enough to cope with the indicators and the headlights on. So there we go.